Hey everybody, in this video, I would like to talk about how to use similarities in competition math. So here we go. I'm going to throw you a right triangle. So imagine we get some right triangle just like this, okay? And we have a right triangle, and of course you got to drop the altitude, and we got lots of similar triangles hidden out here. Let's just try to label this angle as 2-bar thingy, and of course that little angle is going to be congruent to this one. Why? Because of angle chasing. If you call this as theta, that becomes 90 minus theta, that becomes theta. So you can check that the small triangle, the intermediate triangle, and the biggest triangle, they're all similar. All right, so let's just try to label this using A and B and D and E, and let's just try to label as H. All right, so check this out. A squared equals D times D plus E. D times D plus E. And at the same time, you can check that B squared equals E times E plus E. E times, well, let me say D plus E as well because of commutative property. All right, so what do I get? What's the vertical sum? The vertical sum that you can check is that A squared plus B squared equals D plus E squared, which is the proof of Pythagorean theorem, but not because, not limited to these two expressions. We can actually state that H squared equals D times E. And this is how we use similar figures in right triangles and competition math.